sir, and everyone, good evening.
Good evening, Moyabo. Good evening, everyone. How are you doing, guys?
Sir, I am begging you this evening, please
Mm-hmm.
don't teach anything, sir. My light, no, for real, sir, my light are fixed and I have forgot
But
come
we
off a
should be agree
class.
with her.
May I beg you, please?
We agree
I
with
let
her,
me
sir.
say,
Let her take more sleep.
Sir, I'm news for you.
What happened?
Yes, I'ma just eat.
Go away. It's a new year. Go right
Some
away. It's a
nice
new year.
KFC, sir.
May your tummy feel uneasy.
Nope. I love you, sir. I enjoy it.
All right. All right. So, all right. So, good evening, students. I think the spirit working in unison. I I thought to myself, when I was, matter of fact, I just got home in commute and I'm watching the clock and I'm saying, all right, I know I will get
Hello,
home by
Mr.
seven.
Man.
Hi, how are you doing, Crosswell?
Yeah,
Thank you.
I was there, but never remember saying about turn on the mic.
Oh, okay, no problem, Papa. So, so I said to myself that today being the first class, I'm just going to get the housekeeping matters out of the way and just touch on one little area. It's not a heavy teaching. I don't even want you to write notes. I just want to touch on one little area, and we're going to just have could be about a 20 minutes conversation on it. So before 8 o'clock we should be able to finish. So am I getting a amen to that?
All
Mute from
right.
Yes,
across
sir.
yeah, mute from
So,
across
Amen.
well. Mute from across well. Your background is a little noisy. All right. So um just allow me to do some housekeeping, please. Um there are some housekeeping matters that I must address, and I will have to do that tonight. Um and then now the outline, I will share the outline with you, um you know later on tonight, or I'll share it with you through Moya tomorrow. But this is what I want to say. Let me get the big elephant out of the way. Every time I go on to continue my marking, I'm seeing where people are checking every day to see if their grade is posted to Canvas. I see the digital footprints. But let me just tell you what is happening. I had to write a letter, as I told you, to the CCCJ. They give you guys 2 days. I'm very upset about that. I've been looking at the responses to the stuff. I won't comment on those any further than just saying that I haven't looked at them. Um, I am marking. The marking is, however, rather very slow because of some issues that I am experiencing. Now, those were verbalized to the vice principal today. Hence, um, your grades are not in. However, and I want you to hear this however part. I am seeing one person here who I know I saw a prerequisite override for. I am not doing any overrides. No, I'm not doing any overrides. No. I'm also seeing one person here who can attest to what it is that I'm going to say, because I know this person knows. And I'm not going to highlight the person because I said the person just slip into my class and don't even say good night, teacher, but never mind. Um, this is what is going to happen. I already verbalized this to to
Evening,
Mr.
sir. Happy
Parchment.
New Year.
Okay, Lord Jesus, ever make everybody knows how you met your word promise,
Evening,
Stacy.
sir.
Evening, man, evening. So this is what is going to happen. I have done this in the past. I have done this in the past, and I think I have mastered it. The grades are not yet in. I cannot tell you that the grades will be ready this week. Neither can I tell you that the grades are going to be ready next week. Right? The grade processing is very slow. And I want you to let me just put something there for you to understand. Because I know some students can go and complain and say, Dean, Mr. Shan don't give you the grade and he's the only one that don't give the grade. Math is different from any other subject. Let me tell you the challenge that we're having, that I am having. And let me just pick one something. For example, I have not yet touched the calculus one, correct, because I am done for calculus 2. I'm not teaching business calculus. So I couldn't wait. I don't want the business calculus lecturer to be waiting on me. So I took the business calculus, the pre-calculus paper first. The challenge I'm having with the pre-calculus paper is that every question on that final assessment, students had to optimize or model their own question. In modeling their own question, it means that I have 30 odd different papers to mark times 2 questions. It is very difficult. I like this morning I'm up from 4 o'clock. I really am suffering from sleep apnea now because I jump up knowing that I have um these papers outstanding to be marked. Plus there are other deliverables that I must meet. For example, I was in 2 meetings, concurrent meetings this morning. One started at 10 o'clock and ended at about minutes to 12. And I had some interviews starting at 11 o'clock that ended a little bit after that first meeting. So, and I will apologize. I would apologize. It's not of my own volition. Um, it is because of the system. All right. I don't want to go any further in that, but this is what is going to happen. But, sir, what is going to happen to those who are supposed to get the prerequisite override? And how we know if we're going to pass or fail the course? Listen to what I'm saying to you now. I have done this in the past. When there are situations and there are, for example, I'll mark the exam papers. Normally, the exam papers are marked even before sometimes one or two of the coursework pieces. And let me explain that part of it, because sometimes the mid semesters and their students, I know at least one student can tell you true or false. Good evening, Chevy. Well, maybe 2 students who have interacted with in the past, 3 even, from a list here. If the mid-semester exam is not good, for argument's sake, I'll call in students and give a make-up mid-semester. Now, that will take a little time for me to mark, so it is that I can give you a fair chance in passing the course. I have no apologies in doing that, because it is that, some students would have been like a near pass, and I don't submit exam papers or grade sheets, rather, forgive me, where students get a 48% or a 49. I would call the student in and say, listen, come and do over this paper. I can't touch your exam, but I can maybe possibly touch something on the for the coursework. I can give you a makeup mid-semester, or I can resubstitute a coursework piece so as to give you a chance to pass in the course. All right. So this is it. You will all stay with me for Calculus 2 until I have completed the marking of the papers. If there's any student or grouping of students who failed Calculus 1 and as such are not eligible for Calculus 2, at the point where the grades are posted and you see a failing grade, you will demit, you will leave the Calculus 2 class, and then I'll try and put in place a fast track Calculus 1, so that at the end of this semester, you could possibly resit the Calculus 1, and then we could see whether or not a Cal 2 could be offered in the summer, where you can pick up the Cal 2, so that by the time I reach year 4, you don't have the math courses out. Every year I keep saying that I'm not going to do that again, because sometimes I am taken advantage of in the process by students. But this is my commitment, that I don't want anybody to be plugging the system because of my Calculus 1, Calculus 2. All right? So let me just reiterate the point I'm making. Please don't come and ask me, sir, when we're going to get the grades, because it's going to put me under anxiety. Right? I know exactly what must be done. It is a rough process. And I don't want to say too much on it, because I mean, I this morning, 4 o'clock, I got up and I went into my kitchen, and I sat down in the kitchen, and I gave a detailed explanation to the vice principal of academics. And person responded to say that, thanks for the fact that you did a variance report, and thanks for the fact that you are highlighting some of these issues. They are real concerns. And I will, because I told her straight up, I said, I cannot tell you that I'm going to finish it by this weekend or next week, and I just don't know when I'm going to finish, because it is difficult. And also, I'll end this conversation by saying, unless you guys did a terrible paper, I will not penalize you for the CCCJ's limitations. Let me just put it at that. All right. Unless you took something verbatim from the internet and presented it, unless you did a terrible, terrible paper, we will see what will happen. All right. So please just work with me. You're going to come to the class nonetheless. You're going to put in your 100% in the, oh, I should tell you also in the past what I have done. Students for my calculus one who were borderline, like a D plus, I would in the past allow them to do the calculus two, on condition that they are going to be doing a fast track of calculus one with me on the weekend. And it worked for some, it didn't work for others, and it worked for, in parts for other students. All right. So technically, in a nutshell, what I'm saying to you is I'm giving you my commitment to see you through the process. So I'm not telling anybody don't come to class yet until no man, you've been joining the calculus too. At the point where I say, boy, so you really have to go over the calculus one, you don't argue with me. Just take your walk and just come over to me for calculus one so we can just help you to pass that something there, and hopefully calculus two is going to be out. If you are close enough in passing the course, I would say to you, I will allow you to stay for calculus two. I'll give you an override, but of course you still have to do the calculus one with me. If it's an outright fail, where I believe, so boy, makes sense to put in the calculus two because you don't even know how to differentiate, and we're going to just use applications. That's what this course is about now. This course is not me teaching you anything new. This course is a carried forward from Calculus 1, where we're just going to simply be doing applications. Every single thing is application, 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 application. So if you don't know the stuff, you're not going to be able to apply it. All right? That is it for that for now. Are there any questions relating to that? Please shoot them at me now.
I
Good
mean,
evening,
actually,
good evening, sir.
Good evening, Papa.
Nigel, sorry, let me just go quickly. Good evening, sir. I arrived, Raheem here. I arrived late. You were
Mhm.
saying, oh, you haven't started marking our papers as yet.
I
If
didn't
I
say
have
that. I didn't say that. What I'm saying to you is that the process is slow,
Right.
and the grades are not yet ready because of some issues that were previously. Hello?
Yes, sir.
Oh, sorry. I didn't. I mistakenly turned off my system. Right. Right. Because of some issues identified, and the grade the by extension the grade sheet should have come in today. So not today, yesterday. So I was responsible enough to email the vice principal to let her know the difficulties that I'm experiencing. And I highlighted those, and I referenced the letter that I wrote to CCCJ initially, XYZ, so forth and so on. So it's not that I have not started marking. I am marking. What I'm
Oh,
saying to you is that the process is slow. I can't tell you that the grades will be ready for next class or next week either. I'm saying to you, there's no need for you to come to me and say, sir, when we're going to get the grades, you don't need to do that, because you're just going to put me on the anxiety, because I know what I have to do. I know I have to get the grades out, and it is a
understood.
rough process. Sometimes when you guys are sleeping, I am up trying to mark papers. I'm up trying to do this, and I'm up trying to do that just to get them out. All right?
Understood, sir. Understood.
Right. So what I'm saying to you is that I will not ask you to leave the calculus 2 class. Don't even worry about the grade selection, course selection for calculus for this something you're getting close, and I'm going to charge you. Don't worry about that. I know the situation. I've emailed the VP on the situation. I spoke to Mr. Parchment on the situation. Um, so when we get to that hurdle, I will give them a list of my students in the class who I'm going to be doing an override for, and they're not supposed to be paying for that, because I know for me. However, if you have other courses that you need to do, I can't speak on those other courses. I can only speak about Calculus 1, Calculus 2 as it relates to you students. I can't speak about your new venture business something, or your managerial accounting, or your programming. I can't do that. Right? So if you need to go and select the courses for those, go and do your due diligence. All right? Any other questions? All right. So thanks again for being Oh no, am I not being heard properly? Oh no.
Yes, sir,
You're
man.
being
You're
heard,
clear,
sir.
man. I hear you clear, sir.
Oh, okay. All right. Oh, I think I misread that message. Um, okay. Chev, you need to side talk with me. I mean, not necessarily tonight, but one of these nights we need to side talk.
When we can side talk, sir.
Uh,
When we can side talk, sir.
I'm waiting. I'm waiting for that call again, Mr. Nigel, because you were supposed to come back the 2 days ago, 3 days ago, Friday, when we spoke. Anyhow, you need to side talk as well. What was I going to say? Oh yeah, so I think the spirit is working in unison because I did say that I just got in. I said that I'm going to come in. I'm going to need to meet you, do some housekeeping matters. Just introduce something briefly with you so that you can at least have something. So I don't want anybody to go and complain that, oh, Mr. Shan come to class and never teach. I just want to introduce something. I don't want you to write anything. I just want you to look and see what is happening so that I can, you can have something to mull over. Um, I also had to write to the team to remind them that the course is 60 hours because on the timetable only had 2 hours. There was no way I could be finishing the curriculum for this semester with those number of hours. So they put a class, unfortunately, 7 o'clock to 9 o'clock on a Friday. Truth be told, I was really running from another Friday evening, Friday night rather session. But I am cognizant that there are some students in the class not. Okay. Don't forget. Guess what? If you're in year 4, this too shall pass. It's soon finish. Don't worry about it. This too shall pass. Um, I'm going to say something after I finish this thought. Yeah. So, um, yeah, just do what is expected of you. Let me just say something to you, students. Uh, as you get closer to completing your course of study, you're going to have all manner of things happening. All manner of things happening. You get a promotion at work, them require longer hours, you can't get to come to school. For example, you you can now work and therefore you have to go stand up and wait on bus, so you go reach home late. Everything will happen to you as you draw closer to the end. I can tell you this, I've been going to school all my life. All right? And I'm still learning. Things when you believe about all right, this is the time, something else come up. You buy 4 new tires and say, yeah man, everything good. Boom, gas tank bus. Sitting gone bad. Right? I'm gonna say to you, I want you to stick with it. Don't give up. Fight as if you're just in year 1 and you need to get to year 2. Last week, Thursday, I sat in that auditorium, conference center even, and I looked at my computing students, some of whom I was seeing for the first time because I don't teach the students in the associate degree. I only pick up at the years 3, sorry. Year 3, calculus 1, calculus 2. And some year 4 students, if they didn't get through the course, I'll have them for years 3 and 4. And when I see them walk across the stage, and I know the difficulties they may have had, and some of them never have no difficulties with the course, but to see that they are graduating with their Bachelor of Science in MIS or IT or whatever it was a good feeling. I'm walking into the conference center and there are students saying, hi, Mr. Shand. And I know the voice. I say, you are you. I say, yes, sir. I was like, Rockstone. That means I would have passed you. I don't know you. All right. So I'm just going to say to your students, just stick to it. It's going to get rough. It's going to get rough. The calculus 2 is a little rougher than the calculus 1 because, as I said before, calculus 2 are just application questions we're going to be doing. How do we apply the differentiation? How do we apply the integration? How do we apply the limits of a function? How do we apply all of it? application, application, application. So just work with it, stick with it. I'm going to invite you. None of you should sit down and wait on me. Get into the habit, as I told a student last week, work ahead of me. Why I have my recordings in my YouTube is that you can go. Unfortunately, I can't label them as topic under indices or a topic under vectors or a topic under that because I just don't have the human resources to do that. But what I have done is to label the recordings calculus 1, calculus 2, chemistry and the environment, engineering, chemistry, whatever it is. So you know what course you're picking up. Go through those recordings. Work ahead of me. You will be fine. Students, if you put the work in, I don't care whether or not you like maths when they grow up. That's not my concern. Once you put the work in, you will get the result out. You will get your output. All right. So stick to with the process. Don't worry about it. You will finish. As I said before, I normally work with my students for calculus 1, calculus 2. If you don't work with a calculus 1, all is not lost. We still can do something. And if we can't do it in this semester, I will ensure that something can work out. If it's one of you alone, you may have to end up paying a little bit more to have a one-man class to the college. If it's, others of you together, we can do this stuff. I pray to God that we don't have any others doing the calculus 1 and that everybody would pass the calculus 1 and that you all pass the calculus 2. All right. If there are no other questions, I will, thanks, Amanda. I will, oh, that's what I'm looking for. I want to share with you, share screen, but I can't share screen like that, and I need to first open a document. I forget I'm using this device. I just want to show you something very briefly. As I said before, I'll be disappointed if any of you took out the paper and send again right. I don't want nobody to write nothing. Just want to whet your appetite with something. Share my
Full
screen.
already, sir.
I know that. I know you. It's all right, man. Um, start broadcast, and then now I'm going to go to Rockstone. Where was I? Let me know if you see my screen, please.
Yes,
Senior,
sir. See it, sir.
All right, good. So, just one little thing that I want to do there. I mean, I'm not gonna bore you with these things just yet. Just one little something I want to do. Oh Lord, where is that one little something? So my approach is going to be very similar to what I did last term. But is it possible for me though to, that's the difficulty with this thing, I could spotlight with let me see if I can spotlight. Okay, I can't spotlight, but I can write, on the stuff. All right, so let me do red. No, that's why you're gonna, Jesus. Click this and then click red. All right. All right. So this is the only thing I'm doing. I'm just gonna talk about this. If you don't get what I'm talking about, fret not. I'll be going back through this again. All right. So just look at it. Don't write. Just look at what is happening. You know my strategy. I try to give real life experiences, and I'm going to create an experience right now. And say, for example, everybody knows where Devon House is.
yes, sir.
Okay,
Devanos.
great. Devon House. All right, good. So, say for example, someone got abducted at Devon House. passerby over Krispy Kreme next door saw the abduction taking place, but can't tell where the car went. Now it's a four-way intersection. It could go down on Hope Road, it could go up on Hope Road, it could go across Waterloo, or it could go up to New Kingston there. So there are four ways that the getaway car could go. But the person who is calling the police can say it was a white Mark X, heavily tinted, and it has a spoiler at the back. So the person gave as much description. What is going to happen, students, is that once that report goes into control, you'll have police from Half a Tree who will be moving up Half a Tree Road, because they say, how long ago that happened? And the person say, it just happened like 2 seconds ago. The police, once they can find a vehicle, will come out and can decide that they're going to go that side, right? To see if they can create a barricade there. And there meaning, say, like the St. Andrew Parish Church. You may have crossroad police now coming up Half a Tree Road to see, in the event that they don't go down all the way down, like them going 3 miles and them turn on Half a Tree Road, them make the left turn to Half a Tree Road, them can try and intercept them. Police coming up from Constant Spring can be coming down on Constant Spring now to close in on the person. You may have Matilda's Corner Police Station coming down on Hope Road to corner in on that person. And then you may have another police station, people coming down to corner on that person. So what is happening is that you're actually trying to close in on this particular or potential car that abducted this individual. And then now what may happen now is that the police station up, say Castleton, may block that area. So in case them bypass the grid that was created, them can't go up at Castleton for go Portland St. Mary side. And what they may do, Rockford may come and may block out there so. And when them block out there so, you want to go St. Thomas and you want to go the other side of it, you can't go there so. And then you may have another police who is blocking a section. So what you're doing, you're cauterizing that car in a particular area, and you're moving towards the car until you can find where the person is. Question: anybody picture and follow what it is that I'm saying right there?
Sir,
Not
repeat.
All right. Work with me now. Not really? That's
yeah.
fine. Work with me. Work with me. And see if you can figure out what it is that I just said a while ago. I'm starting at this point right here. All right? I want to find the root. I want to find the root that is defined by this equation. That's an equation. That line there is an equation. And I want to find the root. The root of the equation is going to give me the solution. The root of the equation is going to give me the solution. All right? Now, I have this point. That is going to be my initial guess. I'm guessing that's where the abduction took place. What I'm going to be doing is I'm going to be drawing a tangent to the curve. I'm drawing a tangent to the curve. Where that tangent is drawn to the curve, I am going to be extrapolating up to this point. So this was my initial guess. This is not my first guess. I will call it iteration, right? So that was my initial guess, could be my first iteration as well. So which is why I can call it f of x1, right? Please note that some books refer to it as f of x0. So you will have to be aware if when they give you on the exam they call it f of x0, f of x0 be your initial guess. But the practice that I use is called f of x1, your initial guess, right? So I can use x1 as my initial, or I can use x0 as my initial, all right? Now, where I have my second guess, again, I'm going to draw a tangent to the curve. I'm going to draw that tangent to the curve where it hits my x-axis. which will incidentally give me the root. So when I'm solving an equation, in order to find the root, the function is in f of x. The function is in f of x. Once it crosses the x-axis, I'll be able to determine the root of the equation. Again, once I reach the x-axis here, I'm going to extrapolate up. I have this, which now becomes my x3 point, which is going to be my second iteration. Remember, my first iteration is my x1. My second iteration is my x2. And then now it's going to be my third iteration. Now it's going to be my x3, right? So it says there in green after the second iteration. So after the second iteration is really the third one, all right? Because one of them is my initial guess, which can also be used as one of them. Right here, wherever it crosses or touches the graph, rather, I'm going to be drawing a tangent to the graph. All right? This word I'm going to come back to, tangent. I'm going to draw the tangent to the graph. Now, again, similarly, I'm going to extrapolate up. Wherever it cuts that, I'm then going to be doing a tangent. And you can see right here, the tangent gets to a point right here where I end up with my exact root. And I'm able to solve that equation just by doing several iterations. So in this question, I would have gone through one iteration, two iterations, three iterations, and it was on the fourth iteration that I'm able to solve my equation. All right? Now, any questions so far? Am I to understand that that's clear as mud?
Clear as mud, sir.
Clear as mud. All right. Now, let me ask a question though. Is there anyone in the class that can see a relation to what I was trying to create in a real life sense with what is happening here now with what I did with the iteration?
Is it that you're trying to triangulate and pinpoint where the car went, sir?
Absolutely. 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 Anybody remember? Hold on. It could have been in COVID when there was a shootout with police and some bad men on Trafalgar Road. Anybody remember that? And then now there
Yes,
was
sir.
there was a situation where one of the policemen came out of the car and he was taking cover behind the car and people were mocking him on social media. No? But remember?
Yes, sir. Remember.
All right. So it's the scenario that it just came back to my memory a while ago. That scenario that I created earlier with the person being abducted in by Devon House. Let me tell you about that situation. Somebody was killed. Oh, I forget that I'm not supposed to use that word doing this stuff because I got a flag for using a word some time ago. Anyhow,
Unalive, sir. Unalive.
right, unalive is the correct word, right? Somebody was unalived on um Old Hope Road. Old Hope Road, uh around about behind Normal Stadium Gardens. And when the information got to the police, the same situation that I told you, exactly what happened. The police stations were converging to where they believe this getaway car was going. And by the time the police intercepted the car, it was by YMCA in the same vicinity I was talking about to look at life. YMCA, BNS along that stretch here, Pulse area there. And when the police recognized that that was a car that was in it, and they approached the car, a barrage of gunfire took place. Now, I know somebody related to me who was in the, really for something, and the police had to be very careful because they didn't want to lose other lives. All right. So it is something that is really practiced in real life, and this is the mathematics behind it. This is the mathematics behind it. Now, Let me ask you a question. I did say to you that every time I'm drawing a tangent, why do you think that I'm drawing a tangent? And let us use what it is that you'd have learned in Calculus 1 to answer that question. Why do you think I'm doing a tangent?
So is it that I use like different points to solve the equation?
You started off well. Oh, sorry, I lost the screen, right? You started off well, and I was about to say congratulations, and then you went off again. So start one more time. I'm using what?
There are different points.
Okay, different points. All right, press pause right there. Does that give anybody any jog your memory on something? When I'm doing the tangent, when I'm calculating a tangent of something, what am I doing?
That does look like the area and the curve to me, sir.
All right, press pause. I want you guys to be thinking, what color should I use? Let me use blue. What is formed right here?
Sir, point of inflection.
No, not the inflection. No, not the inflection. But tell me what is drawn there in the blue?
Triangle.
Triangle.
A triangle. This point is known as?
Yeah,
Yes, please.
I dropped off. So what's the question?
Now I was asking. I was talking about tangent. I made reference to tangent several times. So I'm asking, what's the significance of tangent there in relation to what we're doing now? What am I doing technically? Every time I'm moving, every time I'm finding the iteration, what am I doing?
The rate of change.
And that rate of change is known as?
Oh, I'm correct. Oh,
It's known as what?
partially correct.
It's,
Sir, oh, can't think.
come on, guys, help her out. She said rate of change. When you talk about rate of change, what are you doing?
Sir, the movement or something.
Yeah, but we have
Everything.
no. What are we doing when you find the rate of change of one
Sir,
variable to
are we
the
differentiating?
duh? You're differentiating.
Oh,
Yeah, man, you're differentiating. Very good. So you're differentiating. So every time I have an iterated guess, every time I move closer, because it's where what it is that I'm looking at? I need my exact root. Every time I get closer to my exact root, it means that I'm differentiating. This is what I'm finding here. So this is going to
yes,
be
yes.
this is going to be y2. This is y1. So the tangent is going to be equals to y2 minus y1 over x2 minus x1, which is really equals to the change in y delta y over the change in x. So this is y, talk truth. See it over here, so y don't. So that is y, and this is the x-axis, don't. Talk to me now.
Yes, sir.
Yeah, man. So one is a change in y over the change in x. So we talk about change. We don't understand. All right. So you have y2 and you have y1. This is when it gives me, that is when it gives me here delta y. Delta y is the change. When I subtract y1 from y2, it's when it gives me a value. That is the rate of change of my y. And similarly, I am doing the same thing for my x. When I say x1 minus x2 minus x1, I'm going to get a value. That value is going to represent the change in x. The change in y over the change in x is really finding your dy by dx. It's really a differentiation that you're doing. Any questions? Understand this? Or understanding it?
That's so cute, sir.
What about the rest of you though?
So why may I look
Yes,
one
sir.
at X1 and Y1 look like at the same value, sir?
What, say it again, Nigel. Are you looking at what?
Now, may I look one triangle there, may I say look like X1 and Y1 have the same value.
Can't. Because X1 and no, okay. So X1 is going to be a value on the x-axis. So it may be it is a value on the x-axis. This y1 value, what is this? Somebody tell me what is that y1 value equals to? Y1 is equals to how much number? Look at it and tell me. What is y1? You can read from the graph and tell me the value of y1. What digit is? Go ahead.
Oh, but me get it, sir, because it wouldn't be on the coordinate would have be different, sir.
Yes, you're correct. But tell me what y1 is. Give me the value of y1. Anywhere along the x-axis, what is the value of
Oh,
y?
sir, 0, 0, 0, 0.
Duh, 0. Yeah, man. So anywhere along the x-axis, the value of y is 0. Anywhere along the y-axis, the value of x is?
0, sir.
And this is why, you see, we're not making the connection, you know. You remember when I talk about the x-intercept? The x-intercept is when what equals 0.
When Y
Why
equal
equal
Absolutely,
0?
absolutely, yes. On the cancer, no, you know, how we do this in our last semester. Yeah, man, are the same things, man. So this is what I'm saying to you know what this is called in the for us now is really an application to what it is that we were taught in calculus 1. So yes, Nigel. So that y1 value is going to be 0. So it shares the same coordinate, you know, as x1, right? So that value is going to be x1 comma y1, but x1 is not 0. But y1 for sure is 0. All right? But the x2, the y2 value is definitely not 0. The y2 value is a value that is greater than 0. Right? So that's what it is that we're doing. So inside here now, we have one gradient there. So look at what happens now. We have another triangle that is formed here. That's why we have to form these triangles, because when we form the triangle, we're checking the rate of change of y with respect to x. So we're getting delta y from here, so, and then we're getting delta x from here, so. And again, we're getting delta x here, so, and we're getting delta y. So if you recognize, in the first one, let me label it as 1, 2, and 3. In 1, you'll recognize that the gradient looks a little steeper or bigger, or it could be smaller. But you recognize that each time I'm moving, I'm going to get a different gradient. All right? Now, it's going to get to a point where I reach right here, so. And that point is going to give you my exact value. Hear me out. Then, sir, what if we bright enough and decide so we're going to go right here, so, and do a tangent and calculate the stuff? It is going to give us this exact value here. And sir, if we go all the way out here, so go to the same something, what is going to happen? It is going to give us this exact value here, because it means that we would have already found the solution to our question. We would have already found the solution to our question. Now, I'm ending right here. Hear what I'm going to say to you. And this is why I want you to do it. I want to give it to you tonight. You can think about it for the rest of the night, the remaining time for the class. You have all of tomorrow to think about it. And then when we meet on Thursday, God's willing. Matter of fact, is Thursday we have class? No? No. Yeah. No, sorry. Tell me the days for class,
3
please.
times per week,
Yeah.
sir.
Which days?
Man, we are supposed to have a Thursday to sir. Thursday
Oh,
and Friday.
okay, so it's Tuesday, Thursday, Friday.
Yes, sir.
Okay. So when we meet on Thursday, God's willing, I want you to be able to even have a little understanding of what it is that we're doing here. The topic is called Newton Raphson. It is a numerical analysis method named after Sir Isaac Newton and Joseph Rapson. So that's why it's called the Newton-Rapson method. And it is a method of finding the root that is going to be done after using successive approximations of the real root. All right? And it is going to be an idea of a continuous and differentiable function. If the function is not a continuous function and if the function is not differentiable, we can't use the Newton-Raphson method. So that's a condition to it. And it can be approximated by using straight line tangents to it. So that's what the Newton-Raphson method is. I can show you the formulation for Newton-Raphson. It's going to be that, don't look at what it is that I have there. Just look at what is in pink. That's the method that we're using. All right. So it's going to be x subscript n plus 1 is going to be equals to x subscript n minus f of xn over f dash of xn. So that's where the differentiation come in. That's where the differentiation come in. All right. So we have to differentiate the function. All right. If it makes any useful for you, I can just say to you that the first thing we're going to be doing is to determine the value, find the value of the iteration, right? You're going to guesstimate what is happening. Remember, I said to you that the caller to the 911 operator will say, the abduction just took place in front of Devon House. The telephone operator should say Devon House on Devon Road or on Waterloo Road, because or on Hope Road, because people can say in front of Devon House and take Devon House. Devon House has 3 gates. All right, Hope Road, Waterloo Road, Devon Road. So the operator should say, which of the roads? Is it Waterloo Road, Devon Road? Me don't know the name. Is it in front of Krispy Kreme? Yes, miss. Okay, fine. That means it's going to be Waterloo. So at least the operator has some information. So you need to know what function it is. All right. So you need to know exactly what your first iteration is. Your first iteration is going to be your initial guess. So once a person says it is in front of Krispy Kreme on by Devon Road, over Devon Road side, that's your first iteration. That is your initial guess. If the person is going to say it is little bit before or little bit before you reach Devon House, and then the operator may say, coming from where? Coming from New Kingston or coming from up Waterloo. And I said, no man, come from New Kingston, and see that happens. So, okay, fine. You know what direction you're going. You're going north along that side. So you can say, okay, fine, going north along Waterloo. So these are things that we use in real life world that has lots of mathematical applications to it, right? When I start giving you the functions, you will see how nice this topic is. Every year, students really gravitate to this area of mathematical investigation, iteration. It's really very interesting. All right, and then you're going to differentiate the function. So you're going to make the first guess. So the first thing that you're going to do is to make an initial guess. That initial guess is going to tell me where the abduction took place. The next thing I'm going to do is to differentiate the function. I'm going to have the function, meaning to differentiate what the function is. And then I'm going to use the same formula, x subscript n, x plus 1 is equal to x subscript n minus f of xn over f dash of xn, right? Xn is just really my first iteration. X subscript n is my first iteration, my initial guess. And then, so this is my initial guess. And then this is going to be my second iteration. So I'm going to be using the first iteration in order to find the second iteration. And then I'm going to be using the second iteration to find the third iteration. Then I'm going to be using the third iteration to find the fourth iteration. Then, sir, can I just go ahead and find the 10th iteration? No, because I have to do it in sequence. Because the 10th iteration may very well mean that I've already passed my solution. All right? So I have to do it in stages. Incidentally, this topic means that everybody must have a working calculator. You have to have a calculator in order to do this. Matter of fact, You must have a calculator because this course is going to be heavily on applications. You have to know how to use your calculator. We're going to be using the exponential function um, heavily. We're going to be using the logarithmic function heavily. And as a result of that, you need to know how to extract your data from those logarithmic or algebraic functions. All right. And then now, the second iteration, note you'll be required to make several substitutions. That is f of the first iterated value, f dash of the second iterated value. You may not have a clue what that says now, but I will explain that to you. And then the final step is step 4. You're going to repeat this process as many times as is necessary until the desired result is achieved, which is your endpoint. All right. So just think differentiation. Um, all you're going to be doing, you just need to know how to differentiate a function, one. And then the other thing you need to do is to know how to substitute into a function, two. And that's all that there is to it. I promise you. I promise you that there's nothing more to it than that. Pretty easy. Pretty fun working with. I'm sure by Thursday, God's willing, I can finish this topic. Any questions? All
Yes,
right.
sir.
Go right ahead, please.
Sir, what's the topic again? Because I dropped off, so I did not catch what this is about, really. Can you just reiterate that? Yeah, since we're doing iteration.
Iteration. Yeah, you learn big word again. Yeah, man. This is called Newton-Raphson method. So you can just look at what the Newton-Raphson method is. For those of you
Oh,
who who would want to run to YouTube or run to Khan Academy or run to any one of those software, math platforms, bear in mind, as Sir said, some of them will use X0 as your first iteration.
sir.
Yes, please.
You know, everybody taking do. Remember, I'm a programming student, so I must know what iteration is. But
You know
big
to spell it?
word.
You know to spell it?
No.
Sir,
All right,
all
sir. I don't think
order.
Moya has those capabilities, sir. I don't think she's done that.
Oh my God. No, it's not Chef.
Oh
Oh my
Lord.
God, my partner in crime coming against me.
I
Oh
tell you,
my.
I have homework for you guys. I keep telling my students, I learned so much from you guys. I was writing a program. I'm not a programmer, but I was doing something in robotics the other day, and I was writing a program, and I did using an Arduino robotic software. I created a display using a stoplight, and I did a presentation last Monday for the opening of the Eureka Campus Smart Classrooms. And I'm not using my laptop to even project it. I'm using my tablet, so I can't even project it now. And I wrote a command for the stoplight for the breadboard to respond to the red, or I should say the green, the amber, and the red. And what I did was to go and alter. um I set everything to run every 2 seconds. So every 2 seconds the light changes. But I was explaining to my audience that so there are some stoplights where, because of the heavy traffic coming from one sector, the stoplight takes a little longer. The red is shorter, but the green is longer. Anybody experience that?
Yes, sir.
Yeah, man.
Sir,
And then
Like
but
right at Mullins and
oh yeah, yeah, yeah.
that
Oh yeah.
road there.
No.
What I
That
saw.
intersection
Like
is just way too wide. Mullines and
right.
Washington Boulevard. I think that's what you talk. It's an intersection that I hate, Maya, because it is so wide. And if you try to be the
No, the
amber,
one where you going to halfway to, sir.
oh, that
Right,
one too.
right
Yeah,
there, right there, so.
JBC, that's so in
Secret
front of the
Park.
Eastwood Park Road. That's so yeah, man, that one worked well too. But the one by Mullines and Washington Boulevard, I don't like. The intersection is way too wide. So the people them always across me, because if I see the amber, I'm not going across, because I'm sure I'm going to be caught in the middle of the road. All right. But so what I did was to put the green to respond in after 10 seconds. and you could see demonstrating live to the students or to the participants how the stoplight took a little longer. All right. No, so what when I was doing the code for that one, I was a little careless in not closing my parentheses and my curly brackets and so forth, so it wasn't responding. And then when I started reading the stuff, I said, "Oh, but I have to close this. If I'm going to let the red do this, and then the other two colors don't do something, I have to close it." And because of the math in me, I was able to do it. It worked, but I need some help. You know, they are using C++, and there was one other code that I was doing that really decided that it wanted to challenge me. You have some bedside lamps where you touch it once, it turns on, and you touch it two times and it turn off. No, anybody? Somebody?
Yes,
No?
sir.
Right. So I was creating a robot to mimic that sort of technology. And so when I clap and some, like you say, Alexa, turn off the kitchen light, and Alexa very fast, and she's going to turn off the kitchen light. So it is supposed to respond to, so a clap should turn it off, and a double clap should turn it on. But for the life of me, there's something that is broken in the code. So one of these days, I want my programmers here. So Maya, I hear you talk about programmer. So one of these days, I want you guys to pull your teacher one side, because guess what? I will tell you, I am here to teach you because I know a little bit more than you know. But when I finish teaching
Right.
you, when I finish
Mm-hmm.
teaching you, you're supposed to know more than me, because I'm giving you all of what I have. So you're supposed to use all of what I'm giving you plus more. So I'm expecting you now to pour back into
Mm-hmm.
me so that I can be
And you know
developed.
what, go on, sir? You know
What?
what, go on?
What?
We are paying you, right? For we learn from you. So you know how it's a little vibrate.
So Chevy, is that you laughing, Chevy? You're supposed to be on my side, Chev. But anyhow, it will only reinforce what it is that you're learning in programming Maya, so it can feel good. But no, on a serious note, if you ask my students in the past for calculus one, calculus two, I give my programmers, my computing students leverage to rotate models, because we're going to be looking at volumes of rotation, both from the x-axis and the y-axis. And now we're going to talk about integration and a little bit of differentiation. And I want to show how things rotate and what shape is formed after rotating. I have had students in the past who will find a SketchUp software and rotate it on screen and show the class. And the students say, "Oh my, this is what is happening." Yeah, man. So we're gonna move the mathematics from the paper and let it be very real. So I'm depending on you. I'll be depending on you when I'm moving into those areas. I will talk about it. I'm gonna go and research it. I'm gonna go and find models, software that we can make the mathematics come alive. This is what I'm doing in the first semester. We not take a chance, and this is why I teach the way I teach. All right. But anyhow, thanks for coming out. If you don't understand this, don't feel no way. Don't feel like the first calculus 2 class to go through the man just um red and blue and green up your headspace, because you don't understand nothing. You will see this again on Thursday, God's willing. Remember, guys, we have a plan. I know I have deliverables outstanding for you. There's no need for you to come and remind me. I know what it is that I must do. You are not going to be disenfranchised. Worst case scenario, if you don't get through the course, I will still facilitate you to do over the calculus one for this semester. And while you take a break for calculus two, if it is that you are very close in passing the calculus one, I will also pray about it to give you an opportunity to do both calculus one and calculus two simultaneously. As per usual, thanks for coming out and thanks for being there with me. I'll give an opportunity for any final question before I take my leave of absence. Any final thought, questions?
One
Oh,
quick one, sir.
Go ahead, please.
You did mention that there wouldn't be a penalty. Is it for this class because the
For this
override?
class. For this class. I can only
Oh,
speak for this class.
okay,
So
sir.
I'm speaking only specifically for the math courses. So I can give you the override, and I can say to them that the student shouldn't pay for this math course. So if your other lecturers are having a similar situation like I am having in terms of the slow marking of those scripts, then engage that lecturer or those lecturers with the same idea of the override request, etc., etc. But for sure, for math, I will take that on. I've done it in the past. I've taken your names, your ID numbers.
Hopefully, this is the only course I have to do.
Okay, me too. I really want to see you guys out. And just a
Because
go
yeah,
ahead, Pastor.
because once I do this, I won't have any more outstanding courses and I would
Good
actually
job.
get the degree.
Good job. Good job. One of the things. Hold on a minute, please. One of the things that I want you guys to do for me is and I want you to start it earlier this semester than some of you did for last semester. I want you to be honest with yourself, students. If you're having a difficulty, say something. Say something if you're having a difficulty. Please don't sit down there and wait until it get too ripe. Please. Because if you do that, you're going to run yourself into a situation where you're not going to be able to recover. And I don't want that to happen for you. I'm here to guide you through this sojourn. Just work with me, please. You get work to be done, do the work. You're supposed to be studying, study the work. Thank you for coming out. We'll talk.
Sir, go eat.
Bye.
Sir,
Go ahead, please.
sir, Moya say or a gift if she got an A.
No, Chevy will buy that gift. Two tins of flash out.
So you know what? You see being him out me earlier. You gonna make it be clear me and Chevy never own a conversation about a gift. Here, him want it.
Well,
I can buy myself flowers.
no,
Yes.
guess what? Anybody who gets an A for my course, I'll give them a tin of flash out. Just let me know which one you want. Lascaux, Grace.
Sir, I have too much of that in my pantry. I don't need that. What else? Sir, but you don't mention nothing about the local lunch or whatnot. I don't hear nothing more, but how are your money done? I was
If I tell you, but no, it's just remember the condition was getting the A's, but because the grades are not yet. Oh no, man, it is still there, man. It is still there. I know you guys are working students. We can plan. Hear me out. We could plan for one Friday night. What's that coming? No, so enough to stay with sir from 7 to 9. We can plan one Friday night. Either we're gonna have class at Devon House and we're sitting and eat with ice cream and we do with stuff. Or we can go down to Gloria's and we do with stuff. Or Chevy will take out the money and we can maybe do Grand Palladium. And we'll drive down to the Palladium on Friday, and by 7 o'clock we just meet in the conference room and just have a class, and then we can have
Sir,
the rest of the
Grand
night.
what?
You know what? I'm going to get myself into trouble. Have a good rest of the night. Have a good rest of the night, students. We talk on Thursday is what time? 5 o'clock or 7?
5 o'clock, sir.
All right. So I see you Thursday. I see you Thursday at 5. All the best, guys. Take care.
Yes, sir.
Nice to see you again, sir.
And nice to see you too, my lovey. Cool.